Okay, now we're going to do practice test 2 for chapter 5. Don't forget that this needs to be brought to class, completed, practice test 2, on Monday. So you're going to bring this on Monday, all completed, so that after our quiz, we can work on practice test 3 as we get ready for our chapter 5 test. Okay, number 1. These are the simplified problems. So we have our reference sheet if we need it. Some of you are getting really good at this and you don't need a reference sheet, but you'll have it. So we have cosecant divided by secant. I would suggest, I always do, you don't have to do this, but I would suggest you think about this fraction as a literal division problem. And then rewrite cosecant and secant as their fractions. So cosecant is 1 over sine, and secant is 1 over cosine. Now I have a fraction divided by a fraction, so I will keep this one, change the divided by to a times, and flip my second fraction. Remember, we always flip the second one. So I'm going to end up with cosine over sine, when I multiply straight across, cosine over sine, which I know is cotangent. So your job was to simplify that, and you sure did. You simplified it into cotangent. This one is harder. In order to do this one, remember, something's got to cancel out. You have to simplify somehow, which means something has to cancel out. And right now, absolutely nothing is going to cancel. You can't do what you did over here with that problem because there's that minus in there. And besides, it's already in cosines and sines. And remember, we don't change cosines and sines. We just leave them because they're our building blocks. So here's what you have to do. It's tricky. You have to remember that cosine squared, and if you look on your reference sheet, we've done it a million times, cosine squared is 1 minus sine squared. Don't even think about canceling, they don't match. And when there are minus signs or plus signs in the problem, you can't start canceling. Only with multiplication can you do that. What you have to recognize is that 1 minus sine squared is the difference of squares. So 1 minus sine, 1 plus sine. And again, this is review. None of this is new. You can go back and watch the videos or look at the worksheets, the practice over section 5.1. All this we've done before. It is hard, there's no question about it. You gotta have your thinking cap on. So I changed that into 1 minus sine squared. Then I factored 1 minus sine squared into the difference of squares, 1 minus sine, 1 plus sine. Now I can cancel, because I'm not canceling part of it, I'm canceling the whole parentheses. So what does this simplify down to? 1 plus sine. All right, it's easy to get bogged down in these problems. It's hard, it's tricky, everyone is different. You really have to be thinking about it. But remember, there's a whole test to worry about. This is one problem. So I wouldn't get myself all freaked out about it. Do your best, do your best. All right, let's take a look at this situation, see what we got here. Looks like we are solving the triangle. And this is different than what we did on our practice quiz. We are actually finding everything. not just one thing. We're finding everything. So we got to kind of look at it and figure out what we can find. Well, one thing we can find for sure is that angle right there. I know that the angles of a triangle have to add up to 180. So I already have a 58 and a 73, so this one must be 49. I just did the subtraction on my calculator. Now, as soon as I wrote that 49 down there, I got kind of excited because look here. That means I will use the law of sines. So sine 49 over 10 equals sine, I don't know, 58 over b. So b sine 49 equals 10 sine 58. We've done so many of these, some of you are starting to skip steps, which is fine. Just do it carefully. On the test, I would suggest that you do every single step so that you don't do anything careless. Then I'm going to divide by sine 49. I'm going to type that in on my calculator, and that is going to be the answer. So b equals 10 sine 58 divided by sine 49, which is 11.24. So side b, wait, that's not b. That's a. I'm sorry, that's a. 58 goes with a. So that is side a. Sine 49 over 10 equals sine 58 over a. If you'd have been here, you'd have caught that for me. Sorry about that. So a sine 49 is 10 sine 58. Yeah, there we go. So side a is, oh shoot, what did I say? 11.24. Now I'm not done because I still need to find side b, the real side b now. So I'm going to do exactly what I just did. I'm going to set up my law of sines, and I'm going to find side b. So I'm going to go back to my original circled pair. So sine 49 over 10 equals sine 73 over b. And then I will do my cross multiply and my divide. Type it in on my calculator. So it looks like I'm going to get 10 sine 73 over sine 49. So I'll type that in. And that will be my answer. So 10 sine 73 divided by sine 49. So 12.67 is what I got for side B, 12.67. All right, page 1 done. Now, but look here, on page 2, we have another solve the triangle problem. So it's drawn for you, so you can kind of look at it. There really isn't anything like the last problem. We could just add up the angles and subtract. Can't really do that in this case. So what are we going to do? Well, we're going to look at it. And we're going to notice that we don't have a match set. So this is going to have to be the law of cosines. And it actually looks just like the ones on your practice quiz, because our angle is 53. Our side then will be e squared. And then in the middle, I'll have 16 squared plus 10 squared minus 2, 16, 10 cosine 53. And I'm happy because look here, no variables. So I'm just going to type that on in. And something happened. Not good, so I'm going to type that in again. That looks better. And then I'm going to square root it. And I got 12.78. 12.78 for side E. You aren't done. You aren't done. What you have to do now is figure out these missing angles. What about D and F? Well, if you notice, look what you got right here. That is a match. So sine 53 over 12.78 equals sine F over 16. And I wish you were here, because if you were, some of you would be saying right now, inverse, inverse, inverse. Yes, because we're trying to find an angle, we're going to eventually have to do inverse sine. Not yet, though. We got to get it set up. So 16 sine 53 equals 12.78 sine F. I'm going to divide by 12.78. If you type this fraction into your calculator, you will get a decimal. The decimal is not the answer. You need to inverse sine that decimal. So I'm just going to type second sine 16 sine 53 close parentheses divided by 12.78. And I got 89.03. And that is angle F. Okay? And then, since I have these two, I'll just go ahead and subtract from 180. And I got 37.97 for angle D. Now, you notice for problem 3A, directions are different. How many triangles are possible? I've gone ahead and drawn two identical triangles. Because remember, sometimes they'll both be the answer. Sometimes I have two triangles. I don't know though. So first I'm going to set it up and see. I have my nice set right here. So I'll do sine 73 over 6 equals sine S over 9. This is going to be another inverse sine problem because I'm trying to find an angle. And anytime I'm trying to find an angle, I inverse sine. All right, so let's set it up. So 6 sine S equals 9 sine 73. Oop. So I'm going to type that in on my trusty calculator. Remember, you have to second sine, inverse sine. Oops, darn, or good, I don't know. I got an error message, which means what? There are no triangles possible. So for problem A, 3A, there are no triangles possible because when I set it all up and I typed it in, I got an error message. Sometimes error messages aren't good, sometimes they mean you screwed up. But on these kinds of problems, when you get an error message, it means there are no possible triangles. All right, let's try the next one. While I'm erasing, you can certainly be setting it up. It's exactly the same as what we just did. The setup is, I don't know what the answer will be, but the setup will be exactly the same. So here we go. Sine 52 over 16 equals sine S over 18. So again, anytime you have sine S or sine A or sine F, whatever, you know you're going to do an inverse eventually. So 16 sine S equals 18 sine 52. Divide by 16. And that is what I need to inverse sine. So second sine, 18 sine 52 divided by 16. Whoops, I got an answer this time. I hope you did too. I got 62.44. Now the reason I drew my second triangle was because there might be another one. So 62 definitely, okay, good. But now I got to check to see if there's another one. If there is another one, it will be 180 minus 62.44. So that is 117.56. Can you have a triangle? Is it possible to have a 52 and a 117? Yeah, because 52 and 117 only add up to 169. That's less than 180. So both of these angles work, and therefore we have two triangles for problem number B. Two triangles for problem number B. All right, one more of these. One more. We need to find angle S. So right here, sine 75 over 10 equals sine S over 8. So we'll cross multiply. And divide by 10. Again, remember, this is sine S. So if you type that in, you're going to get a decimal. That is not the answer. You need to inverse sine that decimal. This is an inverse sine problem because I'm looking for an angle. And the angle is 50.60. So now what do? Now I check to see if I have a second angle. And if I do, it will be 180 minus 50.60. So 180 minus 50.60 is 129.40. Can you have 129 and 75 in the same triangle? No. That won't work. That makes more than 180. So that angle doesn't work. Therefore, there is only one angle that works, so this problem has one possible solution. So So again, remember, when I'm grading your paper, I am looking for that first angle, and then I'm looking for your subtraction to get that second angle. And the second angle is always, always, always 180 minus the first one. All right, now we're finding area. So we talked about this when we did practice test 1. There will be 3 area problems. This is A, this is C, and I'm starting with A and C because of the 3 problems, 2 of them will be, got it. The other one's going to take more effort. But A is an easy problem, and C is an even easier problem. Because when I find area, what are the perfect scenarios? What are the things that make me really happy? All 3 sides, so that I can do Hero's formula, which is the big radical with 4 things under it, or 2 sides and the angle in between, like I have in problem C, because then I know my area is just going to be 1/2 11 10 sine 53. So I would suggest on test day that you do the 2 that are boom, easy, and then work on the other one, because the other one's going to take a little more effort. It's still not hard, but it's going to take more effort. So C is done. C is a no-brainer, 1/2 10 11 sine 53. So I'm just going to type that in real quick. Maybe. I got 43.92. So for problem C, your area should be 43.92. Now, A is easy, but a little bit harder than that, because A, you have to actually do some work. So the first thing we do is find our perimeter. So it looks like our perimeter at 5, 7, 6 add up to 18. So what we put right here, listen to me, half the perimeter. It's called the side perimeter, S. In the formula, it's the S. So this is the semi-perimeter, half the perimeter. So I said the perimeter was 18, so this is going to be 9. And then we'll do 9 minus 7, 9 minus 5, and 9 minus 6. And the order you do those doesn't matter, because you're multiplying. So 9 times 2 times 4 times 3. And then remember, you got to square root it. And I got 14.70. So for this one, I got the area to be 14.70 when I typed in those and square rooted. All right, so there's 3 area problems. We've done 2 of them. We did A and C because they were set up perfectly. I had everything I needed, and I just had to start typing away on my calculator. B is going to be a little bit more challenging, because if you look at B, you do not have everything you need. For problem B, I do not have everything I need, so I need to figure out what I need and how I'm going to find it. So there is my triangle, and I need to find another side. Which side you find doesn't matter, all right? Just find another side. So you're not here to help me out, so I'm gonna say I'm gonna find side C, okay? I'm gonna find side C. So the first thing I notice is that I have 2 angles already. So 63 and 72. This angle is 45. Okay? Now, look what's right here. So, sine 45 over 15 equals sine C, C is 63. Sine 63 over C. I am finding side C. Just because I wanted to. I could be finding side S. I had to pick one. All right, so I'm going to cross multiply. And divide. Now notice, I have my angles. So please don't be doing any inverse stuff. No inverse stuff. Now for this one. 15 sine 63 divided by sine 45. I got 18.90. Now, why did I do that? Because my objective is to find area. And to find area, I love to have two sides and the angle in between them. So 1/2, 15, 18.90 sine 72. Sometimes kids use the wrong angle. I don't care which side you found. If you found side S, that's great. But if you found side S, then you have to use angle 63 because you would be using this and this. So you have to use 63. I found side C, so I'm using this and this, so I'm using 72. So my area is hopefully the same as yours, 134.81. So that problem took a little bit more effort because I didn't start out with what I needed. And it's just like life, folks. If you don't have what you need, you have to figure out a way to get it, right? So I didn't have another side, so I used my law of sines, and I found another side. Once I found that side, then I could find my area. All right, all we have left are our word problems, so here we go. Number one, we got a regular pentagon inscribed in a circle. So here's my circle. Pentagon is 5, so I'm going to put 5 equally spaced hash marks around the circle and connect them. Remember, nobody's grading your picture. You get credit for drawing one as long as it's a pentagon. And I know the radius is 10 feet. In fact, I know all the radii are 10. So if I drew them all in, I would create 1, 2, 3, 4, 5 triangles, all congruent. So I'm going to find the area of this one right here. Okay? Now, how do I do that? Well, it would be super simple if I knew this angle. I think I can figure that angle out. Remember, all 5 of these added up make 360. So each one of them must be 360 divided by 5, which is 72. So the area of the triangle is 1/2, 10, 10, sine 72. I can type that in. That is not the answer, though. The answer will be 8 times that. Oh my goodness. I'm having a hard time here. So times it by 8, I got 380 for the pentagon. I got 380.42. So when I typed in 1/2, 10, 10, sine 72, I got like 47 point something. I just hit times 8. Why times 8? No, times 5. It's a pentagon. It has been a long day. So 1/2 times 100 times sine 72. All right, this is 47 times 5, 237.76. 237.76. I multiply by 5 because it's a pentagon and I have 5 triangles. When would I multiply by 8? I have no idea why I did that, but when would I do it? If I had an octagon and I had 8 triangles, then I would times by 8. But here I'm timesing by 5 to get the area of my pentagon. That will have a unit, that will be square feet. Square feet. Number 2 says I have a parallelogram. So here's my parallelogram. The sides are 10 and 16. And the larger angle is 104. That's my larger angle in the parallelogram. And question 2 says, find the area. So I'm going to do what I did right there. I'm going to split this thing up into triangles. And the easiest way to do that is just to draw in that diagonal. This is a triangle that's exactly congruent to this one. So if I could find the area of this triangle, I'll just double it, and that will be the area of my parallelogram. Well, I don't know what you're doing right now, but I hope you're jumping for joy, because look what you have. Don't you have 2 sides and the angle in between? So the area of the triangle is 1/2, 10, 16, sine 104. See if I can get this right. 1/2 times 10 times 16 times sine 104. Now, for the triangle, I got 77 point something. But remember, I want the whole parallelogram. So the parallelogram will be double that. So it's 155.25 square centimeters. Remember, area is always your unit squared. Whatever your unit is, it's that squared will be your unit on the area. Okay. What's the next one? Oh, I'm going to do the exact same parallelogram. But this time, I need to find the length of the shorter diagonal. So you need to look at your parallelogram. In problem 2, I drew in a diagonal. But that diagonal is not the short one. Wouldn't this one be the short one? So this is the diagonal I need to draw. Now, we talked about this when we did this lesson. It is so tempting to draw in that short diagonal and call this angle 52 and this angle 52. You can't do that. It doesn't work that way. So if we are going to draw in this diagonal, which is the one we need, that's the short one, I don't know anything about these angles. So I'm taking them out of the mix. You don't know anything about either one of them. You know they add up to 104, but you don't know how big each one is. What you do know is, and we talked about this the other day, if this angle is 104, then this angle is 76, because the adjacent angles of a parallelogram add up to 180. They are supplementary because the lines are parallel. So this angle is 76. That's the one you want. Don't be messing with the other one because you don't know anything about it. This is 16, this is 10. I want to know how long that green line is. I want to know how long the length of the diagonal. Now, let's not be confused. We're not doing area. We're finding the length of the diagonal. To find a length, you use the law of sines or the law of cosines. Those are your options. It's easy. Those are your only options. So, do I have this and this? No. Do I have this and this? No. Do I have this and this? No. So therefore, I will not be using the law of sines. This is a cosines problem. So the good news is, my angle is 76, so out here is going to go cosine 76. Over here is going to go the side that goes with that, so that's x squared. And then in the middle will be my combination of 10 and 16. And then once again, life is so good because there are no variables in there. So I can go straight to my calculator and 10 squared plus 16 squared minus 2 times 10 times 16 times cosine 76. Don't forget to square root it. Don't say 278. Gotta square root it. 16.69. So that diagonal is 16.69 centimeters. Don't say square, it's not an area, it's just plain centimeters because we are finding the length. All right, one more. What do we do in our last problem? We are finding the area of a regular decagon inscribed in a circle. So there's my circle. Decagon means 10. So I'm going to split this up as best I can into 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Connecting those. Kids, please don't spend an hour trying to perfect your picture. Just want to get the general idea. There's your decagon. The radius is 15. Now, if I drew in all of my radii here, how many triangles am I going to get? 10. It's a decagon. I need to find the area of one of them, and then I will times it by 10 because it's a decagon. So how am I going to find the area of the triangle? Well, I'm going to do 1/2, 15, 15, sine that angle right there. This angle right here. How am I going to find that angle? Well, I know that all of these added up make 360. There's 10 of them. So each one has to be 36. So my area of my triangle is 1/2, 15, 15, sine 36. I got 66 something. But again, remember, that is one triangle. To get the area of the decagon, you're going to take that area that you just got times 10. So I got 661.26 square inches for the area of my decagon. Caught myself in a couple of really glaring mistakes. So I'm happy. If you think I made another mistake in the video, that's great. Bring it to me Monday morning. First person that brings me the error, if I don't know that I made one, but if I did, first person that brings me those errors, that error, more errors, I don't know, extra credit. So you find something, let me know. Remember, bring this completed practice test with you to class on Monday. See you later.